As our final section in this overall review of the new features in Java 8, I want to talk about the available attempt to fix the mess that we've had up to now with the date and calendar classes. The date and calendar classes in java.util have been awkward and ugly from day one. If you want to see how not to design a class, take a look at java.util.date sometime and see how virtually the whole class is deprecated in favor of calendar, which honestly isn't all that much better. Many people, many developers over the years have used a separate library called JODA.time, J-O-D-A-time, as a nice alternative to the date and calendar classes. At long last, the people developing Java contacted the people who put together JODA.time and had them build a new date and time package for Java. That package here is the java.time package. Now the java.time package is similar but just different enough from JODA.time to be confusing. So I actually have an advantage there because I never really learned JODA.time and I could just focus on this. But those people who are familiar with JODA.time will already be familiar with the concepts, just the syntax is a bit different in different places. Taking a look at this, a lot of it is based on the idea of an instant or a local date and local time. Now a duration is a time between instants, and a period is also available as a measure of time between two values. Now we have local date, we have local time, and we have local date time. Local date is just a date, local time is just a time, local date time is both. And then we have corresponding ones having to do with time zones. A zone date time is built in as well. We have new enums for the months and the days of the week. If you've used the calendar class with its various integers for January, February, March, you'll know that they all start at 0, unfortunately. January is 0 and February is 1, and etc. Now we have a month enum, an enumeration, and the constants are all listed in there explicitly. I have to tell you, though, that if you actually look at the value on these, they start at 1. So that January is in fact 1. But you can avoid the whole issue simply by using the enum. You could say month.January, for example. We also have an enum for days of the week. So they point out, as part of the package description, some of the principles here. The idea is that instant is a numerical timestamp, and the range of instants that are available in java.time goes forward and back approximately 1 billion years. So you don't have to worry about an overflow on that. Local date and local time I mentioned, and local date time is both, and then a zone date time adds in a time zone, which can be accessed with a zone ID. So a duration is a measurement of time along the timeline, meaning that it's useful with instants, and a period is the amount of time in units, and then there is a chrono unit enum that has different options for that. So there's the month and the day of week enums that we mentioned. Year stores a year on its own, year, month, month, day, and various offsets as well. And they have other comments about some of these classes, but I think it's time for me to simply execute some of these. So here is my demonstration of a bunch of the capabilities of java.time package. First of all, the method for getting the current instant is called now. So instant.now will return the constant right now. And by the way, all of these values are immutables, so that you don't have to worry about them being modified. They're all thread safe, etc. So I'll print that out. I'll print out now. Then I'll take now, and it has a plus method on it that allows me to add values to it that take both a value and this thing called a chrono unit. As you can see, chrono unit is a class that has these various measures in it. If I look at the documentation for chrono unit, it also is an enum, and it has a whole series of constants like days here. So this will add 1 day, and then I can get a duration between now and then, or between then and now. And I could print that out both as the duration itself, also converted to days or to hours. Then I could add in another day, and that returns a new instance of this class, so then I could chain a call to add in, of all things, a half day, if you like, and hours and minutes. But if I'm going to do seconds, milliseconds, or nanoseconds, those have their own special methods just for that purpose. And then I could print that out. So again, this is just putting it through its paces. Here, I will use a local date. So instead of dealing with an instant now, and there are methods to convert between them, I'm going to instantiate local date for the current date, and I could print that out. The factory method of is used to specify year, month, and day. So here's Groundhog Day this year. In 2016 was in February 2nd, and I could print that out. Whereas the first day of spring was March 20th of 2016, and I could print that out. Now, by the way, the first day of spring fell on how do you know? You have a get day of week method. So we could find out what day of the week that happened to be. Then, of course, I can do the until method to find out the number of days between Groundhog Day and the first day of spring. And I can specify the chrono unit, in this case days. So I could say there are this many days between Groundhog Day and the first day of spring. And, of course, the joke is that there are 6 weeks and approximately 4 days between Groundhog Day and the first day of spring. So, of course, if the groundhog sees his shadow, you've got 6 more weeks of winter. That's actually shorter than the actual number of days between the Groundhog Day and the first day of spring. And I understand it's a really long way to go for that joke, but easy enough to do in this particular API. After that, I grabbed all the available time zone IDs and put them in a set. That is a big, big number. So instead of printing them all out, I just printed out the total number, and you'll see there are hundreds of those. As with any collection, I can turn it into a stream. I can filter them by some condition. I'm looking for just the ones that contain the word America in it, and then I'll print those out. The of factory method also applies to ZonedDateTime, which takes, in this case, a local date of, and there is March 13th, and a local time of, and there's 2:30 in the morning. And I picked this day specifically because in this time zone, there was no 2:30 in the morning. That's the day that the clocks went forward, and therefore, even though we thought it was 2:30 in the morning, according to the clocks, it's 3:30 in the morning, and I want to print that out and make sure that that works correctly, and you'll see that it does, in fact. The last couple of things I want to do is show that the ZonedDateTime of constructor or factory method has an extensive set of arguments, of overloads if I want it. There's year, month, day, and again, I probably shouldn't put in a number. I should put in month.march again. And there's a wrong second type argument. Actually, this one did require an int of all things, so I'll leave it alone. At any rate, then there's hours, minutes, seconds, milliseconds, and then the zone ID as well, and I'm just using the system default. So what I'm going to do here is print them. There's a new datetime formatter using an RFC. I can also do an of localized date time, which says I want this to be in the long format with locale France. So I can even specify a locale and print that out as well, and it makes it easy to internationalize whatever it is I happen to be doing. So let me execute all of this, and you'll see the results. So first of all, there's the instant.now, which returns the ISO standard, year, month, date, and then a capital T, hours, minutes, seconds, milliseconds, time zone. After adding a day, there is the extra time. That's the duration with the toString method on the duration. Of course, in days, that's 1 day. In hours, that's 24 hours. When I added all those other pieces, the half day and the hour, minute, second, etc., this is the result. When I call LocalDate.now, that's instantiated. There's Groundhog Day. There's the first day of spring. The first day of spring happened to occur on a Sunday this year. And there are therefore 47 days between Groundhog Day and the first day of spring, which is 6 weeks. This year, it's 6 weeks and 5 days, which means that since the groundhog saw a shadow, that was in principle a good thing. At any rate, there are 585 zone IDs. Amazing. And here is the list of the ones that have the word America in it, just scrolling past all of those. There's quite a number there as well. Then here is the print of the zone date time in America like this, and that shows me which zone ID default I'm in. Oh, I'm sorry. This is actually the one that does the daylight savings. So I put in 2:30 in the morning, and what I got was 3:30. So that worked out correctly. Here's the print with the date time formatter with the RFC in the long form, and here is the one that would print it with locale France, and you could see all the different possibilities here. So it's a very rich API, lots and lots of classes available, lots of different pieces you can work with, and people will be gradually switching over to that in the future. So hopefully that will give you enough to let you get started with that API and dig into further documentation on it.